Let's see if we are live at 1 o'clock in the morning. Probably not a good thing to be doing this at 1 o'clock in the morning, but I spent the last 3 hours cleaning up my workshop, even though you can't tell, trying to find an AT Tiny 45 chip. And I was adamant that I had some, but all I could find was 25s. And in the end I was giving up and putting everything away, and then I realized that I had previously bought these generic AT Tiny boards that I've been using for the bridge between the compass sensor and Linux. So these are I2C bridges, so I can plug them into the PC and they show up as an I2C bridge to Linux. And they've got AT Tiny 85s on them, so they'll do the job. I'll just take one of those. Hopefully they do not have the reset disabled on them and demand that I use high voltage, because I don't have my high voltage programmer handy. Alright, I seem to have a bit of a problem here. Oh, Rigo. Anyway, so I've got a general bag of goodies, which hopefully should contain everything I need to build this. If not, I'll just take a 5-second walk that way. I've got my printout board view, overlay or whatever, a terrible schematic which I did up in 10 seconds, it's terrible, believe me, it's terrible. Everything's wrong about that schematic. But there really isn't a lot to this particular board. It's a very simple board. So we'll just get one of the... Now this is actually revision 2. This green one here was revision 1, but within about an hour or two of me submitting this one to be manufactured, I changed my mind and decided I would make revision 2, and you can see there's a substantial difference between them. The main thing is this one should hopefully hold in the hand a bit easier, and yeah, you can press the buttons and stuff like that. The USB and AT Tiny side is all the same, so it's really more a case of the same circuit there expanded out. I have got a problem on this one that I didn't properly make sure that the USB lines, the D plus D minus, were the same, and yeah, all that sort of stuff. So we may have glitches with the timings. I'll just build it and find out. Usually at this sort of speed they're fairly tolerant, but you never know. Anyway, in here we've got a bunch of different switches. I'm not sure which ones I'm going to use. I've got, I've actually still have a few more switches coming, but they're also with my AT Tiny 45 chips. So it's, who knows when they'll turn up with current COVID type behavior going on. I'm basically just going to be experimenting here as to what I can do, and I've got some smaller surface mount ones as well, or tiny little 6mm square ones. Now the idea that I'm sort of thinking of is that I'll have one primary button in the middle, and then I'll just sort of switch around. So like say this nice reasonable looking button here, which hopefully should fit. It does. Okay. Okay, so that works. Game switches, I have actually got them on the other projects, like the open board views, not open board view, the open broadcaster switcher, but they're too big. The keyboard switches, they're too big. So like if I go back forward, it might be a little bit small on the 6mm. Now the difference between I've got that one and this one is this one will actually take a cap, like you can put a keycap on it. So it's a square top. You can put a different... That actually feels pretty good, that middle one. It'll probably only last about 5,000 or 6,000 hits and then it'll die, but we'll see how we go. Hey Mike Sims, Miles, Barry, James, hey Wayne's Noob Repairs, eh? Mr. Magna is here. Greg, apologies if I miss anyone. Well, I guess really the first thing for me to do before I put the switches in, because the switches have obviously got the highest profile physically, which makes them a bit of a pain to what do you call it? A bit of a pain to solder them in first, because then everything else is going to rock and roll around. Okay, just put those over there. Let's zoom out a bit. It is very trivial to build these. So about the hardest thing I've got to do is take the 85 off here and put it on there. Hey Christian. Realistically, I shouldn't even need this. I will refer back to it, but I shouldn't be having to, because I've built so many of these USB bridges before. It's sad though that I now have to use microscope. It's very tragic. Yeah, so this is the I2C bridge, and I'll just take this 85 off here, steal it for good measure. Hey Barry, you may not be able to stay long. Grandson wants to do cheese pizza. Oh no, you gotta have pineapple on top. How else can you make a Hawaiian pizza? Probably going to melt the plastic off this, but oh well. Miles, I can't imagine any manufacturer with their right mind these days would be using AT-Tinies for USB stuff. Realistically, now that I'm thinking about it, I actually could have used this device as the yeah, I could have just used that and put the switches on it. But I kind of like the idea of having it as a complete all-in-one handheld. Hey Keith. We're going to do the old-fashioned way of this and manually place them. If I ever do manufacturing though, at the very worst I'll do manual pick and place with a stencil. But this will do for first off. Yeah, I think I need flux. I don't know how I used to solder in the old days without flux. To be fair, a lot of the solder that back then had quite a lot of, they'd be using 0.6, 0.7 mil diameter, maybe even 1 mil diameter if I was crazy. And I made a mistake here. I actually should have put the resistors on first, but oh well. Doesn't matter. We'll live. Live and learn. This solder that I use does have flux, but it's very low. Yeah, there's only so much you can cram into 15 thou diameter. Oh man, this is fun. So like I've got all of these little tray arrays. And I used to do a pretty good job of assembling or manufacturing devices all day. Boring as hell, but boring's better than starving. All I'm doing there was just putting a bit of solder on each of the first pins. Just makes it easier for me to put them down. Right. And I'd use my own homemade vacuum pen, made it out of an aquarium pump. There's two ways you can do it with an aquarium pump. If you're really lucky, you can get a pump that has a reversible valve. And so often you just turn the valve 90 degrees and you get, instead of blowing air, it sucks air. But the other way is you put a pump you put the pump in a container, and then you have the outlet of the pump blowing like a hose going out of the container, and then you have an inlet onto the top of the container somewhere. So basically, in effect, the pump's creating a vacuum in that container. Trying to decide what color LED to use. No, because it depends. It was depending on the valve. Some of them, okay, yeah, there were some that you had to flip the whole valve assembly, but there are others where you could actually rotate it and the intake would move in place of where the outtake was, the outlet. What have I got here? That actually looks like a 603 LED. I'll put a yellow, green, or orange. Choices. 250 millicadmium green. No, that will blind you. That's too bright. We'll go for an orange. Nah. Yellow, green. The reason why I didn't bother with orange is because this board is yellow. Okay, got to get our polarity right, and it's not an 805. That feels like a 603 actually. Fine. I don't know what color this one's going to be, so this will be luck of the draw. If we can even... Damn it. Rodrigo really was luck of the draw with them. Some of them were easy, a lot of them were junk, so which is why a lot of the time you ended up just simply doing the pump-in container trick. Okay, now one other design stuff up I did is these diodes that I picked. I don't know what I was thinking, but they are too small for realistic things for me. They're just, the diodes that fit on there are incredibly tiny. Fortunately, I do have some, but in my third revision, I'm certainly going to be changing them, because these are just way too small. I mean, they're not iPhone small, but they're small enough. This is actually leaded solder, I think. I actually don't know, because I've got a few different pieces of solder that I've ripped off, and I don't know which is which. Yeah, we'll actually switch to leaded just to see. Okay, we've got some leaded here. Sorry, lead-free rather. And now I'm going to be mixing everything up because I've got both. Now the purpose of the diodes in this circuit are a very crude, very crude voltage regulator. It's not even a regulator, it's just more of a limiter. Okay, so that was lead-free solder that we just used there. That's SAC 305 solder. It's pretty good stuff. Yeah, if you're going to get started in lead-free, then SAC 305's probably your best bet. I will say something, having the micro pencil does make building these a hell of a lot easier. When I was doing the manufacturing, I had a very nice iron, but it was still one of the old cartridge element irons. And as good as it was, the best I could get was about a 0.8 mil tip. And it made soldering a little bit tricky at smaller scales, particularly if you start going. 402 was sort of getting a little bit annoying. Most of the time I just use stencil, but you still ended up having to do a lot of rework with the reflow oven. You know, it wasn't a perfect process, and I made mistakes, or the temperature was wrong, or the paste was a bit too thin, you know, all the usual sort of mishaps. How thick is this board? This is a 1.6 mil standard sort of board thickness. 2 layer, 1 ounce copper. Yeah, basically your very standard board. Okay. I need me a pair of 68 ohmers. Two of these. 603s are so massive compared to what we're used to. Interestingly though, when I started out with manufacturing, I initially was using 805 size parts. Well, I very quickly changed down to 603. But these days, if I've got the room, I'd probably stay with 603. Especially too that I have got dozens upon dozens of reels of parts that I still haven't used. I've got to use them one day. Okay, 68's the top. This is where I made the mistake. This 68, the lines should have been there, and yeah, basically I messed it up. I messed up the routing of it. So like I said, we may have issues with connecting because of timing issues. But I'm kind of hoping at 1.2 megahertz, or the speed, you know, that this generally runs at, or is it 12 megahertz? 12 megahertz, sorry. Kind of hoping we will get away with it. Okay, I need a 1K5. Hey Jim, good evening. I wasn't sure if you'd be awake, Jim, so I didn't send you an SMS because I didn't want to risk waking you up. Get out. Oh no, I've got a big boo-boo there. I put that resistor upside down. That's really bad. Really bad. And I didn't put flux on that. Obviously I'm kidding, but that is, when you're building your own stuff, you often will curse at yourself for the fact that you did not orientate the parts all the same reading direction. Like, it should be left to right, top to bottom sort of thing. What have we got here? We've got a 10K that's got to go there. going to be so pedantic, Travis, that when I'm finished with this, I'm going to have a lovely pizza with pineapple on it. Alright, so that's that bit done. Let's stick the USB connector done. I've kind of done the wrong pin. That's okay. These are 603s. Nice big Duplo Lego size 603. Should make sure the data pins are actually lined up. Yep, they're good. I actually can't see what I'm doing, but I'm just going by feel. Feeling that one didn't quite go. Yeah. You can definitely tell that you're working with lead-free solder there. Hey, did we solder the other end of that 68 there? I don't think we did. It's the only trouble when you do the pre-soldering of one end is that you can often forget to solder the other end. I know that because I've actually had to have a manufacturing recall to my customers for a couple of devices. You can tell that the lead-free doesn't wick quite as nicely. It's not too bad, but it's definitely, it's no lead solder, that's for sure. Gibbo, it would probably help if I ran at a higher temperature on the tip, or the tip had more thermal mass. Yeah, I think we're gonna have to be happy with that. So like, you got leaded solder, lead-free. Yeah, you can certainly see there's a difference. Not as shiny, yeah. No. Definitely. Alright, so that is the essence of the project. Little hot air assist, possibly, but for now we'll just, okay. So at this stage now we need to see if we can even flash the unit. Let's see. No, you're the wrong one. You're the wrong one. Let's see, this should do the trick. I make sure everything's non-polarized so that I can completely botch up everything. God damn it, I'm blind as a freaking bat. That's right. We'll actually flip it the other way around. Okay. Rightio, let's see if this even gets recognized. This is a very well used programmer. You can tell by the amount of grime and gunk that's on it. I'm just going to clear my bench a little bit. Makes it easier to make less mistakes. And we'll worry about our button selection after. Okay, now we have to bring up some programming software. No, JCT, you didn't misunderstand. I mentioned it before. I said that I made the mistake that I didn't do the differential pair correctly. So we'll see how it goes. A 12, it's not going to be super critical. There basically just means there's going to be a smaller window where the overlap's going to be correct, but it should still be okay. We'll see. And if not, then I'll just respin the board. But I figured, well, I got these boards, but we'll see how they go. I mean, I've done some pretty damn disgusting stuff before, so it wouldn't be the first time that these projects work when you're really expecting them not to. Sorry, I downloaded the project at the wrong place. There was the big fat ground plane on the other side. Alright, so this is the original code, but I've got modifications to this design compared to what they have. So I'm going to presume they got... So the first thing they've got is the damn fuse that I've got to make sure that I don't disable the reset line. Let's see. Which one do they normally use? PB5 is the one that I don't want. Okay, so that is actually that one there. So we'll delete that. The reason why we don't have a high voltage programmer, and I only need 3 pins, so it makes it a bit easier. Let's just go to where they... Damn it. Should be good. Now I've got to find out where they actually set the key. This is new code to me. I don't know what they have. I sure hope this works, else I'm in big trouble. TL866, I don't know, maybe it will, but I don't use the TL866 for this sort of work, so yeah, I really don't know. Alright, stay in keyboard report buffer, so we want to just simply have return, tab, and shift tab. Now my middle button is coming off pin 3. So PB4 is the middle one, we want that to be enter. Got my pen and paper. Oh, I still use the /* comment. Like, if you're from C, old C, you tend to use that a bit. Okay, just looking at what they've got here. Okay, so we want the return. What the hell? I should have looked at all this before I engaged with this live stream. Well, I suppose the first thing I should really try is to flash it, but we're going to have to modify their make file. Let's see. Where are they doing the make? They're not using a make file. Alright, we'll steal one from elsewhere. Someone's got a few projects. What have I used? PLD escape. You can see how old some of these projects are. 2009. Yeah, that's a while. I think it was 5A3 is the one I want. I suppose we should read the README. Oh. Want me to go to a website for instructions? I don't like going to a website for instructions because of the fact that what happens if the person loses their website? Oh, Miles, nice. Nice stab there, going for the old, trying to say that I'm using Arduino. That was unduly cruel. For those who are not sure why I'm grimacing, it's because, well, I don't do Arduino. Okay. Okay, I've got to change the high to DD. Okay, so 5F should become DD. Someone hit cap locks. Okay. I still don't know how we're supposed to be compiling this. And I've lost everybody's chat. Pi is the modern day easy way out. Okay. Target should become main. What do you want for low fuse? C1 MDD. That's what I was worried about. I think the main thing you'll notice is when you look at the source code compared to an Arduino one, is that there's none of the excessive dribble. That said, I suppose with the Arduino, sometimes there's less code, but more often than not I find you end up having to write a bit more code and it's not quite as clear as what's going on. Okay, come on. Let's put my face up here. You can all get sick of that. Watch me grimace as I do things. Yeah, I'm really surprised that this doesn't have the makefile. That's you know, yeah. I mean, I've got the one I put in there, but that's not good enough. I'm just trying to think of The other, I need my OBS, the OBS switcher one, because it's going to be similar enough. It uses the same driver. Aha. Yeah, I saw that, Danielle 49 over there. That's kind of ludicrous. Now the only trouble with this is the scene switcher uses a Mega 48, but that's okay. We just change that. Yeah. Make sure we get those fuses right. What was the fuse supposed to be? DDC1. And this is all incorrect because that's referring to a Mega 48. Okay, %S Mega 48 tiny 85. It might work. CPU is going to run at 12,000. I don't know actually. God damn it. Righty. It is not liking what I'm trying to do. What a nuisance. Never goes easy. Like I said, I should have tested this before I came into here, but the thing is, I simply, I didn't have a suitable AT Tiny. But then again, I suppose the alternative is I should have used an AT Mega 48 and then used a crystal with it. But that's the nice thing about using the tiny 45 or the tiny 85 is that they don't need a crystal because they synchronize based on the USB line. I'm going to have to see if I can find someone who's built it for Linux. Let's see, make file for USB AT Tiny 45 key. No, someone here has done something a little bit better. I know, you're all blind, you can't see. Yeah, where did they go? AVR, micro. What is going on here? Okay, whatever's going on must be because compiler is not happy with the... Yeah. Must be constant in order to put into resection. Okay. Alright, so what it probably is that when this software was written, which is like 10 years ago, the compiler wasn't quite so pedantic. Where it is now, so we have to go along and appease it. Which is, I hate this. Wonder if I can disable what it's complaining about. No, must be constant in order to put into read only section by means of attribute. It's only about 20 lines. Crikey. It's not that it's using a deprecated method, it's just that it's doing something that the compiler now wants you to explicitly set up. Like it wants to see the const word in front, and it's not going to be happy unless I do that. Normally you can put a compiler flag in to tell it to just not bother with that, but it's not even giving me that. Often it will come up after here and it'll say, do you want to use -w no const complaint or something like that. Anyway, so what have we got? 455 USB driver to H. Okay, here we go. Redefine prog mem to include const as well. Yeah, I guess I worry about what sort of knock-on effects you're going to have from that. Do I even have C tags on this? For a moment then I actually thought that said fart flash. Yeah, that's very immature of me. Very immature of me. Hey Ron Rogers. It's probably broke. Probably broke everything then. Oh, far out. Nope, that didn't like it. No, I gotta go do it properly. Was probably going to be a quick way of doing this, but let's just... yeah, 4, 6, 7, 4, yeah, these are all... Okay, let's see if I can just quickly... they're all going to need it. The trouble is, what other things is this going to break? Because usually once you put constant into these things, then the functions that you pass stuff to or whatever, they're going to go complain, and then... yes, yeah. Let's see. Variable must be constant in order to put into... What are you complaining about? USB drive C70, okay. Okay, so this is where that other mentioning of putting constant in there, but I'm going to do it this way. I'm sorry. I know some people are going to hate this, but I prefer at least to slightly not butcher it with a side effect that I'm not going to be aware of when I come looking back at this code. Never. Yeah. Okay, we're down to 2 now. I'm pretty sure of that. Yeah, there we go. I've probably missed one by the looks of it. Conflicting types. Alright. Joy. 14. And 142. Okay. Now what's bitching about? USB config clock kilohertz is not one of supported non-CRC rates. Great. Totally. Oh, I agree. I have no frickin' clue. Oh, man. Yeah, I'm kind of stumped. Hash define USB clock. Oh, okay, I have to set FCPU. Alright, so we actually want... let's see, we want 12800 FCPU. And I better make sure that I actually flash it to that. I do know that they have that remastered Diablo, but I haven't seen it, as in I haven't had a chance to play it yet. I haven't downloaded or anything like that. Son of an SOB of a goddamn son of a... Yeah. Now what do you... 239 in there. Seriously. This is the trouble when you deal with code that's 10 years old. Variable descriptor report must be constant. Okay, yeah, that's fine. But where is that coming from? There we go, this is where it is. Alright, we're down to something that we actually can resolve ourselves. 224. And that's this. We don't need any of this. Hey, Warren. Hey, it builds. Hey. Check size. Wow. Do we still use check size? Nope. I know I used to have check size for AVI, like it would let you see what the binary size was, but it's not really going to matter in this particular case because we've got an 8K chip, so it was mainly being used probably just to verify that it would fit in the 4K chip. So where's that being called? Ah, yeah. Right, so we don't need that. Does this do check size script? Blah blah blah. Whatever. No one cares. No one. I'm not going to care until it breaks. All right. Now we see if we can do a make flash. Okay, that's fine. And it was trying to use the right. Okay, all right. It's trying. So now it's time to switch over. To the overhead. Send some power to this, make sure I get this right. Probably botch it and everyone's gonna die. So I'll do a quad view so you can. Let's see, maybe sudo. Nothing. What is the bet that this chip is already been flashed in a way that it needs a high voltage version? I bet you it's that. Programming operation not supported. So I can see the device. I don't know, is this... Well, people say... What's the difference? How do you say it? Yeah, it could be the fuses, but it should still at least detect the device. Yeah, let's see if we can actually see if it sees the chip. I forget now what the terminal mode was. No. Operation not supported. Connections. Nothing. No, it doesn't need a driver. I have a feeling that chips on those boards that I just took it off, I have a feeling that they have got the reset pin set in such a way I need a high voltage programmer to activate them. Yeah. No. I can sort of at least verify. What I can do is I'll put a AT2025 on there, and then we'll be able to see whether it actually works or not. The programming side, that is. Yeah. Fire truck. Let's see. Yeah, we've got a shonky little 25 in there. No, injecting voltage won't help really. It might be possible with the that other programmer I have, but I don't really want to get into that. I'd rather instead just fix some MacBooks or something while I wait. Yeah, so unfortunately, see, that's a little tiny 25, so we'll just have to go with that. This here is one of my old projects. This is a bit of a prototype board. It was one of the first switch mode voltage generators that I'd like. It would take a single cell lithium pack and boost it up to about 5.5 volts, and then so this is the boost circuit section here, and it also had a magnetic on-off switch, so you just sort of like, it was a toggle, a bunch of LEDs, and I don't even remember what the hell that was for, but yeah, so it was an old prototype, and now, so it's been sitting there probably for 10 years doing nothing. I seem to remember I ran into problems with the switch mode side of things. It had a nasty habit of burning diodes for some reason, even though I was using the right diodes. And it was around about that time that I was starting to just pretty much sort of say stuff it to everything. Okay, I've got hot glue on pins 8 and 7, but we'll put up with that. I have no idea what the coding is on this particular device. So since this is a 25, obviously we'll switch to that. And this should hopefully respond? No. Alright. Alrighty. Looks like I am out of luck on that. So maybe there's hope yet. That's all good. I've got another programmer now. I know this one works. It's just got the wrong... This is a very fine pitch programming header on it, whereas this is the classic Brutes header. And this is why I have multiples of these. And this one's got a green line instead. Did something then. Yeah, what have I done? Okay, so pin 1 reset, that's good. That's positive, that's ground. Did I get my miso and mosi mixed up? I hope not. That would be hilarious if I did. Okay. Because that would make sense. Okay, so miso goes to miso, mosi goes to mosi. That ground is down here. Something. Oh God, Paul, your stuff is terrible. Oh yeah, there's ground up there. Wait, what? Oh God. Yep, Paul's effed up. Oh, flying trucking heck. Flippin' rockin', God, flop me. Alright, the problem here is this one is supposed to be ground. Oh, Lord. What have I done? Okay, fine. 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 Unbelievable. Yep. Well, at least I stick to my tradition where... it usually takes 3 prototypes for me to get it to work. Alright. The number 11 knife is coming out. Now, son of a flippity flip flow flip flip flip. Yeah. Nothing a bit of hackery can't fix though. This level of stupidity deserves a Dremel though, I think. Should have known there was something amiss because I should know that I always put the ground on as the first pin. But this is the trouble, is when you don't do these projects often enough, you start to do dumb shit like that. And you forget your own little in-house rules. Good thing this does not have internal layers. Yep, it's not a project until you put bodge wires on it. Now, where it's going to be fun is that actually leaves this here isolated, but that's okay. Actually, no, it's not going to be... Anyway, Paul, just shut up and cut the wires first. Okay, so we have freedom from ground now. And I'm going to do a very severe cut there. Beautiful. No, I've got no other... Yep, okay, that's cool. Fire truckingly truck. I'm trying to think now. You know what, the best thing I'm going to do... No. Think, Paul. Don't just do. Think. The best thing I'm going to do is put the cap on the other side and just bridge it between those two. I use Eagle 7 or something like that. It was the last one before Autodesk came in and ruined it. No, the mistake I made here is that I forcibly did something, and I didn't run my DRCs. That's what happens when you don't run your DRCs. Because if I'd ran the DRC, it probably would have said network conflict. Oh yeah, Robert Cook, yeah, I've had to do that. Particularly, when it would, when it would take months for you to get a board to be spun. And so the last thing you're going to do is, the last thing you're going to do is wait another couple of months while your product needs to go out. Interestingly, the bodge wire that I'm going to need here, which will go from... Well, actually, I need two. This has got to go to ground, so we'll just scratch that. That's one. And, that's only going to matter for the programming on this. Still, I'm very glad that I didn't just go out and spin off board number 3 before I had checked this one. Sarah, thank you very much. KiCad probably is better these days. When I was doing it, KiCad was unfortunately not a good option. And unfortunately now, of course, I'm stubbornly stuck in my ways, aren't I? Creating marvellous truck-ups like this. Now you realise how fine these... That is what I would normally call crowbar wire on a MacBook. Well, at least there you have it, folks, all very easy for me to make plenty of mistakes. I was kind of hoping I'd have an exposed ground point around somewhere over here, but... I'm trying to think, no, that's not even ground. No, we'll just do the scratch out method. Just gotta get the angle low. Do. Well, I didn't use a tantalum because they're tantrum. No one uses tantalum caps anymore. What's wrong with using a ceramic? You don't need tantalum for this sort of work. In fact, I reckon these days you probably have to get a really good reason why you're using a tantalum. Ceramics have got excellent capacitance for the size these days. I mean, the frequency response can be a little bit iffy, depending on what you want to do. But overall, they're pretty good. And if you need something, yeah, you've got the solid polymer, e-polymer. So it's pretty hard, I think, to warrant going with tantalums anymore. And in terms of social ecology, it's kind of nice to not be using tantalum too much more. The environmental impacts are a little nasty. That's funny, Miles, because yeah, I mean, MLCCs rather, sure they'll crack and they'll misbehave and all that, but tantalums, I don't know, they just do it in a far more spectacular fashion with a nice big fat purple flashbang in your face, and you're blinded and you're like, ah, and then you breathe in that air. Yeah. Yeah, JCT, I'm glad to see I'm not the only one that's come to that sort of conclusion. I've very rarely have I ever had anything come out on the first spin. Sometimes on the second, but almost always on the third. Third is like, there's just no way out. Okay, it actually caused my machine to shut that port down. Okay, we are back up and running. That's some seriously not funny stuff. I should have known something was up because I saw the LED flashing. Okay. Yay! There we go, that works. Okay. Okay, so now we'll put the 85 back on. Man. And of course projects never go according to plan. Blame it on the customers for changing goalposts. I only wish I could blame customers because I am the customer with most of my projects. Well, I guess there's only going to be one iteration of this. As in, one build, rather. Instance is what I should have said, not iteration, instance. I've got this on very low air, if you're wondering why it's seeming to take forever. Hey, 6 hills? Yeah. And of course I have people say, why do you put so many headers and different types of contacts for your parts and stuff like that on your boards? And it's because almost always the part that you think is going to work, either it's the wrong shape or wrong size, or you realise when you put it together and you're like, oh, yeah, that doesn't work. So like this is for my switch area. I've got 1, 2, 3, 4 different switches at least. You can probably bodge your way around. Oh, 5 actually, because there's a surface mount 6x6 version on there as well, if you want to put it over the top. But yeah, you got to factor in the likelihood that you've made a bad choice on what part to use. Like a good example is these diodes here. You know, they're just too small realistically for me. I need to go up to the next size, or just simply add slightly larger sizes there. Okay, so we've got the 85 on there. Let's see if we have any luck with this now. Are they using regular ISP for that part? Yeah, who knows? This is the ISP header I've used from 12, a long time ago. Yeah, many, many, many years ago. I just used whatever I had at the time, and I suppose I've never changed since. It's not really a standard ISP header because it's not keyed. Okay. Okay. Ah. Is this device signature is 1EFFF? Okay, that means I just didn't hold down the contacts, that's all. And our low flash is wrong. Our low flash, wasn't that supposed to be C something? I could have sworn it was supposed to be C1. Yeah, it is. It's supposed to be C1. The high fuse is right, but the low is not. I'll see if I can make fuse to do it explicitly. Oh, shite. Okay, it didn't. We just got lucky in that case. We did indeed. Kind of pushed our luck there. That could have gone very badly. Okay, that's better. Alright, theoretically, now if I plug in this... Oops. I'll plug this in. We should see it show up. It's having trouble, damn it. I wonder if it's having problem because the... Damn it. No. Well, that's either because of my awful routing. Device not accepting address 37. Yeah, let me just check with my other board. But I'd say it's because of that. Or I've got the frequency rates wrong. That's probably what's going on. So that's what it should come up like. Yeah. I think the first thing I'll explore here is that the frequency rates are wrong. And that's something that isn't explicitly explained. Okay, the other project that I was looking at, it actually uses a CPU speed of 16.5 megahertz, so we might duplicate that and might have a little more success. Yeah. That does not work. We're going to copy the one from our other file. Oh, that's terrible. Use the yank method. And what do they want? 165. I might have to change something in the main program as well. Shouldn't have to, because it should actually be read by that defined value in the make file, but okay. And we still haven't even got to the point where we can even check to see if the buttons work. Okay, calibrate us. Okay, core clock is 16. Okay, so I got it wrong. Yeah, core clock is 16. Okay, that's why it possibly didn't work. Okay. Let's try again. Welcome to how I spent most of my life all those years ago. I'd spend nights doing this stuff. Make flash. Okay. Where did everybody go? There we go. Jim, you're still with us. Crikey, mate. Pushing it. Yes! It works. That's what it was. Oops. There you can see, new low-speed device, 4-key keyboard. So it works, we just had to get the right speed on it. So I shouldn't have to do anything more until now. Put the switches on, decide how I'm going to, what keys it's going to make press. Alright. Man, this actually probably would go 10 times faster if I wasn't dealing with everybody here. No offense to you all, but yeah, it does slow the process down when you chitter chatter. But that's what we're all here for a bit of fun. So we've got a bodge wire and yeah, some makefile hacking. Okay. I suppose the other question is now, as a user, would I be more inclined to like the circuit board with the components facing up when not with the buttons, or like this? Not sure. I guess we'll just see. It shouldn't really make any significant difference. For now I'm going to make all three that large button. Actually, you know what, I'll just do one to start with. Yeah, if I put my glasses on I might be able to solder this without needing the microscope. spongy. Damn. When you start soldering big pieces like this, you realize how tiny the micro pencil is and how it needs some assistant heat. This thing's just absolutely minuscule. Need some fatter solder. There we go. My roll of 60-40. Oh, right. Okay. The flux in this particular brand, when it burns, it certainly gives me a lot of memories, reminiscing the old days of having Dick Smith electronics kits, stuff like that, back in the 80s. I will probably in my lifetime not use this solder up. Nice and clicky. Tell you what, it used to freak me out though when people, when my friends, well, people who were also doing soldering at the time, they would hold the solder in their mouth or they would chew on the solder, and I'd be like, well, yep, that's really great. Yeah, can see that working out. Yeah, 60, because everything I use now, of course, is, what is it, 6337, yeah. Okay, let's go to... Okay, let's see if anything happens. Ah! Okay, we have the number 2 coming up. Oh wow, it auto repeats. Ha! Oh gee. Yeah, it really is like a keyboard. Alright. Let's stick the other 2 on there. But in all honesty, I kind of want to change my tip. What have I got? Good old chisel 1.2. That'll do the trick. I think debounce is already built into the circuit. There's no electrical debounce put into it. No cap and resistor. See, 2 of your meters went missing along with other tools just for lockdown. Threaded police action, saw stuff. Oh, that's awesome. So you got your stuff back. Is it still in usable condition, or did they botch it up? It's not much fun getting your gear back and finding out that someone's just gone to town with it and ruined it. House of Moth, it should do because, well, I imagine it should, because it just simply presents as a keyboard, so I can't, and it just produces whatever keys I tell it to produce. You know, like enter, tab, and shift tab. Yeah, I do not miss this really, to be honest. I am no fan of pin through. I never have been. When surface mount started making an appearance, it was like, oh finally, thank goodness, I can finally see what I'm soldering at the same time. Kind of surprised they didn't end up doing radio frequency amplifiers more, because they usually are all surface mount, just simply because you'd mount them all on the one side of the copper blank. OSIS, well, that's what these three things are here for. They're little headers to go off to something else. Okay, so we've got our keyboard back. 124, 124. Alright, now we have to go along and work out how to make it so it does. So what do we want? We want 2 equals enter. 1 will equal shift tab. Yep, okay. What is it? 2 in the morning? 4, nearly 3 o'clock in the morning, for flip's sake. Geez, Jim, what are you doing up? 4 equals tab. Okay. And I need to reduce the value of that resistor because that green LED is really not showing up. It's a nice lime green. Yeah, Travis, 3 is missing because 3 is the pin 1 on the chip, which is the reset pin. And if we enable that, then we have to have the high voltage programmer, and I don't have one of those. I don't want one of those. I just don't use them. And I don't need it. Okay. If we've got our Vim window there, yep. Okay, so now we've got to work out how to set the buttons up. So it's right now it's doing, what are we doing? 1, 2, and 4. Now I've got to read this and try and understand what it's trying to tell me. Standard USB keyboard report buffer. 6 simultaneous key presses. Okay. Ah, okay, alright, yep, alright. Alright. Okay, so this here would be the key code, I'm gonna guess. So they got 76 there. And that would be decimal. And what do you got? 76 is L. Oh, okay, maybe not. I was trying to work out where they have set it up, so you know it's the 1, 2, 4, whatever. Okay, input array, key array, 6 bytes. Oh, okay, alright. So 30, that's going to be the number 1. No, that's number key 3. That's weird. That's off by 1. Oh, because it's not ASCII. You're using the USB standard, right? No, ignore. I'm just a bit stupid. Okay. We can cheat here because I've already done this in the OBS thing. they did this a lot easier. Yeah, see how all this... I might just actually copy this. It's going to be a bit silly, but... copy. Okay, so what do you want? Pin 1 is Shift Tab, Mod Control. Why no tab? What the hell did I just flash with before? Where is my Flex Board View version? Does Woolies still exist? Yes, Woolies in Australia still exists, Woolworths, and it is a... Okay, I've got to look through this and see if I can find my file. It's got to be here, so foot switch Flex Board View. I'm pointing at the screen, you can't see one. Idiot. That's what I'm after. Right. Damn it. God damn. Man, I'm losing my mind again. Yeah, Woolworths UK, Woolworths South Africa, and is different to Woolworths Australia. I can see I had to bodge in a few fresh things there. Okay. Copy. Paste. The build report is different to mine, the one I want to do, so this is going to be a little annoying. Ah. Yeah, I'm using return, so it's 4.0. Remember, these are the USB HID codes, not the ASCII codes. Yeah, Scoop Dog, I worked over there for a number of years. I'm just trying to work out which way I'm going to go here, whether I'm going to go my way or their way or... Why did you do that, Paul? Why? Oh, for goodness sake. Do not code at 3 in the morning. It's always bad. You may as well be drunk coding. Someone hit cap blocks. Okay, so... let's just try pin 2 here. So we want key is actually going to be key... Really? Line 270. Key return. It's because it's return pool, not... Okay, key return. That should be fine. And key 4. That would be key tab. Oh yeah, Gobble, I know. Or what I usually do is I accidentally, I think I hit Control S or something like that, and it goes into, and the key record, and it goes into the record mode, and you think nothing's happening, and then you finally realize, you hit Control Q, and then you come out and you hit something else and it just spews all the garbage on you. And it's like, that was good. That was good. Okay, so this has to be key tab again, but report buffer needs to change. Interesting, I noticed that they don't reset report buffer each time. Interesting. Report buffer 0 equals 1. What was the bit mapping I needed? Mod shift left. Back in the day, zeros and ones. Back in the day, you had a hole or not a hole in your punch card or your ticker tape. Now, I think what I'm going to do here, this slightly slows down the code, but it has to happen anyway, is I set the report buffer to be 0, the first byte to be 0, because otherwise what's going to happen is when I hit the shift, then the next time I press the key it's going to come back in and it's probably going to still be set at shift, so my enter is going to become shift enter and so on and so forth. So I could be wrong, it might not compile, but we'll see. Yay, might not compile. Jerks. 217. Alright, that I don't need anyway. Okay, that's good. Let's flashinate this. It is a bit dodgy the way I do this, but it works. I could use a proper connector and everything, but I've always found holes in the board and a header does the job fine. Mostly. Fingers crossed this keys actually do the trick now. Alright, so this should produce enter. Okay, enter's working. Well heck, let's bring up FlexBoard View. I don't know why I'm caring about what part I'm looking at, because I'm going to kill the data anyway. Okay, so enter, shift tab works, enter didn't work. Okay, shift tab works. Okay, it works. We've done it. I guess I should celebrate a little more. Let's see, how does this feel? How do I feel? Because that's really what's going to matter in the end, is does this work in the situation that I'm trying to make it work? So the idea being is I have a board here, I have the ground of that board attached to whatever side of the multimeter I need, like positive for the diode mode or ground for the volts. And I'm under the microscope, and I've got the other probe here, and then I'm just doing, this, like, yep, value in, naturally of course there's wrong there, like value in, made a mistake, come back, value in. Okay, there, see that? That's a bug there. Okay, shift tab works. Interesting, shift tab. It's not clearing that shift key for some reason. Hey Hedgehog, thank you. Haven't seen you for a while. How you been? Thank you for the £9. Greg, you shouldn't ask such personal questions. It's a caps lock? No, it's not a caps lock. No such thing as well. That not so much unintended features, but misunderstood features. Yeah. Let's see. Yeah, so like I'm setting that to mod shift left, but why does it sometimes stick? Timing, I don't know if time, I mean it's, I'd be very surprised. Oh, you know what I should do is actually on the release event it should be reset. Or should it? What did I just do then? Alright, I know what I've done. That should only be in there. That's why. Can't believe you people didn't see that. Scoop Dog, timing issue. Oh yes, Scoop Dog's got it. He's got the scoop. Oh shit, yeah. Don't try and flash that when it's not even connected. No, my language goes into the gutter when it starts getting late. No, it's not a falling edge reset. Oh, I don't know. Look. Context. All in the context. It was being reasserted when the button was released. So that's why it applied to the next button. Hey, you missed all the fun though, Sonny, I'm sorry to say. Anyway. Alright, so let's try it in Flexboard view again. Pull goes into Lewis mode. Okay, so let's try edit the board data on this. So shift tab, enter, shift tab, enter. I can't track that because it does stupid shit. I mean stuff. Enter. Okay, that's working now. That's working as it should. It's not doing the little dodgy jump. So we have sorted out the firmware, and I suppose I could probably make a couple of these, with the bodge, but that's not very nice of me. Better to probably wait a week. Let's see. Interesting. I wonder if this could fit. No, it just doesn't quite fit into a 2K. If it was like 2000 bytes, we could probably do it, but not 2330. Was it show key? You want to go show key? What is it? X key, is it? No. Couldn't get a file descriptor referring to the console. Oh, that's fantastic. "15 press, 42 release, 15 release." Okay, so 42 is... yeah, whatever. 28. Okay, so 15 is shift. Oh no, 15 is tab. 28's enter. 15's tab. 42 is shift. Yep. Anyway, it doesn't matter, it works. Oh, we do have one feature we need to fix up. It is perhaps the most important feature of it all. And that is the brightness of the damn LED. I mean, it's a travesty that it's so puny right now. So that was a 1K resistor. Interestingly enough, we now have the proper soldering tip for this sort of work. Is there a reason you didn't use more buttons? Yes, because I only wanted the 3 at the most. There really isn't a lot more, and it's very simple because you have your central, your back, your forward. If I wanted more, I probably would have just gone out and got myself a Xbox or PlayStation keyboard thingy. I really want something around about not 390, maybe 220 ohms even, if I really want to blind myself. Where's my electrics box? What have I got here? I got everything 300 to 560. Let's try 330. Look at that, these resistors are so big, they've got numbers printed on them that you can actually read. And when you solder this way, you always end up with a seesawed part. I'm going 330 because I know these LEDs, from what I remember, are quite bright. I don't want to be blinding everybody. Nope. It's a lot dimmer than I expected. Alrighty. It's bright enough that I think we should go red. What do you reckon? We should go red, because that's kind of still blending in too much with the body color. I got high output red, 1206 size, green, red, low output red, $20 millicandela. Oh, that's the one I was originally going to put on it. I don't have blue. Blue is forbidden. We do not use blue. If you have to use blue, then you fail on all design accounts. Hey, Thomas Logic. Just gonna hide that LED over there. Flick that part off into goodness knows wherium. Flux it up. Get our polarity rightish. perfect. Let's see how much of a mistake I've made this time. Yeah, it's bright. Come on. That's yeah, that's quite distinctly bright. You're not going to miss that. That's too bright. That's just too bright. That's one of my high output ones. Anyway, it does the job. Yeah. And that's only that's at 330 ohms. So and it's what a 5 volts, 330 ohms. Yeah, it's pretty good. Yeah, 1k resistor probably bring it back down, but then I probably won't be using the high output reds for that. We'll try a low output red. Hopefully no one's going to be daft enough to say, why don't you just put them in parallel? Retina display. And flicked off. Beautifully done. Easy peasy. Can you make a video about Open Compute Project Atomic Clock? No, probably not. No, got too many projects. I don't think I'd be able to do that. Alright, that actually isn't too bad. In reality, that's good. That's what you'd consider an actual pilot light, not a make you blind light. It looks like a little coal ember, doesn't it? That's pretty cool. I've never looked at them directly like that because usually I've got them blaring at extreme brightness, and doing what I'm doing right now would result in something akin to blindness. I'll look at it from edge on. Except there's a freaking connector in the way. You got to admire the fact that we have LEDs and so many other amazing things. It's just so impressive that we've got this solid state optical device. No real excessive heat. Produces a nice light. A red tesseract color. I know what you mean, yep. Alright. Technically I would have said, yeah, I suppose it depends here. Red on its own is good enough to say it's on. I do prefer green for the sake of saying status good. But to be fair, this is not a status indicator, it's purely a power is coming from the USB state indicator, as opposed to you have USB connectivity and away you go. The other thing we've worked out here is that my botched up, what do you call it, data pair traces has not caused it to not work. So I didn't think it would. I mean, at least in the third iteration I will actually do it properly anyway. Let's see, chat's degenerating. I think it's time for me to go. Model Bodger. Oh wow, that's funny. When I inserted the programmer, it actually sheared the wire off. And the only reason why it programmed still is because the pin was crushing up against that wire. Yeah, we'll bodge fix that properly. Actually, that's a bit of a not quite the correct terms to be using. Bodge fix it properly. The worst thing is I'm about to do this with a 1.2mm chisel bit. You've got to just touch this stuff because otherwise it will desolder it from over here. Okay, that's done. It's pretty damn ugly though over here. Paul starts beautifying stuff and destroys the board. Steve, I wasn't going to bother with the container to be honest. I figured that's why I sort of went for the slightly larger board rather than the original, so that it could just be handheld as is. So like it'll just be handheld like that. So you're not actually touching any of the contacts. I mean, it doesn't matter if you're left or right. The other thing I hate with pin through is the fact that you got to clip everything off the back. And then you get all little twangers in the room. Do not miss pin through. Oh, multicolour LED. Yep. Alright, you people are all going to get banned at this rate. So there you are. It's done. We had a few hiccups there. Not bad for the first actual assembly prototype. Second design, but first assembly. I'm pretty happy with that. Now, I've got to make sure I put all my programmer stuff back in the right box. The number of times I have lost programming headers or all sorts of things, yeah, it's yeah. Alright, so my two AVR programmers are in. I guess no, you belong in a different box. You belong in the box of failed projects, well not really, but this is, see, I have used clicky keyboard keys, but I just feel like it's just a little bit too wide for easy thumb use. What is this stuff I've got here? More current meters. One of my original USB current meters. This, I sent one of these to Lewis and he lost it. Freaking useless. This was before we actually had them as a general rule in the repair industry. I mean, they were around, but they weren't quite the same. So I ended up making this one myself. It wasn't anything special, it was just a plain old boring shunt type device. Use a tiny 45, I think it is. Tiny 48. Yeah, let's see if this still works. Yeah, it still works. It's got a few beaten up pins on it. But I did like that it was very clear. So we'll show you obviously your cumulative data transfer and your instantaneous current and instantaneous voltage. You could do things like set the threshold for when it would trip so that you didn't destroy any equipment that you had attached further on. I can't remember what the other buttons are for. Yeah. Oh yeah, that was the limit one. There's a reset. And that was a dummy button. Nothing could be done with that one. Anyway, yeah. Another project that is now dead. Yeah, it will be held in the vertical orientation like that. Oh, are you meaning for selecting back, forth and center? Because I did experiment with doing like up and down like that, but I actually found it more taxing on the thumb than just doing it that way. That was my personal experience, so I built it according to that. So there's nothing to say that you can't still put the data entry in just using a normal keyboard, you know, just punching in enter and stuff like that. But this does make it a bit easier when you're under the microscope because you know where your fingers are, you know, the keys pretty innately. Versus the vertical. Oh, right. Okay. Well, I see what you're saying. Yeah. Sorry about that. Gotta love it. The difference with this one. Get out of there. The difference of what this was for. This is for a scene switcher. So I had this mounted just on the edge of my bench here. And so if I wanted to switch scenes, I could just, you know, pick which scene I wanted. And for Open Broadcaster. But I don't bother with that anymore because I've got the automatic switcher for the microscope and that covers me for 90% of what I need to do. That's okay. No, I mean, yeah, you've only got a few seconds to try and explain things, so it happens to all of us. I might give it a little bit of a 12 because I want to. It is late. It's 3:20. But I wanted to see if I can capture some 840 values. Let's see, where is my board? Yeah, here we go. Particularly around the SMC. Alright. So we get the multimeter set up. Now I'm going to do this with the hand switch as opposed to the foot switch. ALJ Rogers. Okay, so we're going to start out diode mode. So therefore the black one's going to be the one we're actually probing around with. And the red one can just clamp onto that. I'll switch back into quad mode just now. Okay, let's see how this goes. Enable the meter. And we need to get into diode mode. Right. Alright, my bad there. Okay, I just realised I've done something dodgy. Because I was expecting to go left to right, but because I picked a group of pins, it's not guaranteed. You actually have to follow the screen when you're doing group pin selections. Alright, so let's try that again. So it's actually that one, and then that one, and then third, fifth. Yeah, that actually works pretty good. Yep. Just checking to see it. And yeah, all our green data blobs are there. I only have the green there to let me know where it is, as opposed to needing to have that there. House of Moth, yes, I'm using the clicker that I built just now. So let's try another block. So let's try this group here. The reason why I like to collect these pins around the, like, that are the test pads, is because often it's the only way you can get access to a lot of these ones. Edit selection of pins. But the downside is that it's a little bit tricky sometimes, as we have just seen, following. You really got to follow the dot, you can't just make the assumption. Okay. But it's still quicker than doing it the other way. Okay, that's it, they're all done. The reason why I'm doing the SMC at the moment is because I could have done with that data the other day. The DigiSpark. Well, I guess the DigiSpark is basically just going to be the same thing as what I've had, that I stripped the 85 off. The reason why I went with doing it in a package like this is so that I could hold it in the hand all as a single unit. Because yeah, I mean, I basically took this 85 off something like a DigiSpark. Okay, where are we? I mean, obviously it's not identical to DigiSpark, but yeah, the concepts, they're all basically the same concept. It would be cheap. I mean, these will work out pretty much just as cheap, and besides, I'm paying for them to give to everybody else, so yeah, no one's going to be, people aren't going to be coughing up money for this. I'm sending them out to people. just going to go over to this area. Kind of curious. This is the board that we had the other night where the ISL was the reason why everything was going so horribly slow. Alright, so now obviously we can't get to the pin that's under the under the ISL, but we can see that there is a test pad out there, so we're going to hit that test pad, assuming it is out here. Yep, there it is there. And then there's another one there. Okay, now, okay, so that's the underside of that cap. That test pad. That cap there. Oh man, you're making me go all the way up here. Seriously, where are you? Pair of resistors. Oh yeah, I see you. Okay, that one I'm gonna have to skip. There's nothing local for me to get to. Okay. Yeah, look, I mean, I was going for the foot pads, the foot switches, and I do still have them. But I have to say that using the hand switch is actually easier, particularly when you have to do things like skip to the loo, my darling. Anyway, yeah, when you got to skip a value or something like that, it's much easier. Whereas before, I would really have to twist my foot. Okay, skip to the loo. Yeah, shut up, Paul. Yeah, another skippy. Oops, really damage that ISL. I'll be in big trouble if I do that. Don't have enough stock of them on hand. Yeah, this is certainly working out nicely. Skip. And you may think it's a little bit sluggish and slow, but believe me, it's faster than the alternative option. Skip that one. Oh, come on! You want me to go all the way up there? Oh, alright, there you go. Seriously? Have I got that right? That's interesting. That's it? That's all done? Yeah. Well, when I say all done, there's obviously a couple there that I didn't capture. I'll just send those ones up first. And let's have a look at the ones that we couldn't capture. So, PPBAT, G3H, and see if we can capture them somewhere over here. Okay, so it looks like way in the corner, we've got that one there. I've just noticed a little bug. Well, not a bug, but a thing I could do to improve. Oh wait, no, I know what I've done. View. No. There we go. So we've got. Okay, so this pin here. Where do you? Switch your value. 0.6131. But how do we not have that? How did I miss that one? Must have been just out of range or something, I don't know. Anyway, I missed shouldn't have missed that one. But I did. 356. Yeah, that one was just a little bit out of our visual range, that's why we didn't capture that. $608. Charge aim 608. Okay. I really should just round it straight to 0.61 anyway. I know what's going to happen. Okay, BMON's already there. I was suspecting that would be the case. And it is the same. It's one of the few ones that I actually have to go to the other side of the board for. Six, 2, 3. Yeah, that one's going to be hard. Not sure I'm going to be able to get that one. It's only got that one pin there, and you can't measure it externally, so it's not really going to be relevant in that case because you just can't get to it. Which means when you're testing, you're not going to be able to test it anyway. Pardon me. And I think that... What? How did I miss that? It's 0.6. Alright, all our data values are in. So that will help people diagnosing possible issues on the 840 board. So we added probably about another 40, 50 values into that. 162. Yeah, we've done pretty good there. Yeah, I think we started out of 110, now we're 170 or so. Yep. Alright. Okay, well, I think that will about do it for tonight. Yeah, 3:30 in the morning. It's a little late. Not quite any of the diagnostic sort of board repairs that we normally do, but you know, it was a bit of a different thing to go ahead and check this board out. I will have to remember to obviously update the changes that we had to do, particularly with the ISP header. Interestingly enough, if the chip was already programmed, it might have been okay, I think. Maybe not. Yeah, anyway, I'm not going to think it too much. Yeah, I'm out of here. Alright, I'm done. Thank you all for being here, and I'll see you on the next time. And I'll probably be adding more of the values for Flex open board data for this 840 board maybe tomorrow and the day after that. And then I've got to send it back to the customer. That's what I'm doing mostly these days, is when I get a board in and I fix the board, I will then capture the data off the board for open board data. It's about the best way I can think of to add the information while I can with a known working board, because I don't really carry a lot of known working machines myself. So could you do auto capture off value stabilize and more than short to ground? That's what it's already doing. You may notice it sort of wiggles around a fair bit and then changes color to black at some point, and that's because it's averaging the values and making sure it's within a particular range. So it's already doing that. Remind me of Michael Hutchinson from InXS. Well, that's probably the first time anyone's ever said that to me. I do know who Michael Hutchinson is. I actually went to his concert way back. Crikey, what was that? It would have been about 1989, 1988, something like that. Yeah, before he unfortunately left us. Alright, I'm out of here. I'm leaving you now. I'll see you next time. Take care.